Now, the last lesson was all about analyzing and inspecting a string. Today, or this lesson, we're going to look at actually modifying the string. But I have to emphasize a few points that you need to recall. Remember that we don't actually change the original string unless we want to. By default, it creates a brand new string that we should be storing in a separate variable. However, we have the option of overwriting the original data should we choose to. So let's take a look at that. Again, we're going to start off with 3 variables. Now I have modified things a little bit from yesterday's lesson just to handle a few scenarios that I'm going to be setting up for you. First of all, we still have our word variable that's equal to hello world, but our phone number I put in Quebec format today, just, to make sure everything is all up in the up. So we're looking at this. We have the country code, which is 1, followed by the area code, the residential code, and then the local code. So we have all these things. I have multiple different types of characters in there outside of numbers that aren't numbers. And of course, at the very end here, we have our new word variable that's used to maintain the modified version of things. Okay, so let's go take a look at this and break it down. Again, we're going to be going through a whole bunch of different operations, and I'm going to show you the code representation of this. And the code today is a little bit more complex because I've gone through a whole bunch of different types of scenarios to demonstrate to you all the different things that we could be doing here. Okay, so first up, the first operation is a very simple one. Basically, it does exactly what it says. It converts all the letters in text A to uppercase. That's it. Nothing else. That's it. So what I've done here in the 2 examples is in the first one, I stored it in a new variable, new word. So I said new word is equal to word.toUppercase. So that means that new word holds hello world in all caps. But word still holds its original version. It hasn't been changed. The alternative is to say word is equal to word.toUppercase. Now the original variable has been replaced to hold the new value of all caps hello world. So that's the difference between storing it in a new variable and overwriting the data. If you want to make successive changes, so you change it a little bit and then change a little bit more and then change a little bit more and you're building on your changes, then that means you need to be storing it back into the variable. Otherwise you lose those changes and you're basically starting over from scratch every single time. So if you need to make successive changes, sequential changes, then you're going to want to store it back in the original variable. So 2 uppercase, great. Well, if there's a 2 uppercase, there must be a 2 lowercase, and of course there is. Now, this type of operation, these operations are mainly used when you're getting data from the user and you don't care what case they type in. So for example, if you ask them for their name and they write in Bob, but they write it in as capital B-O-B, well, you don't care about those capitals, for example, if you're just setting up like their username in your system, whatever you're doing. You just want Bob all lowercase. It's easier for you to compare against and do other types of manipulations that you're going to see later on with this information. So this is when you would use things like 2 uppercase and 2 lowercase. It forces a case, so it makes comparisons later on easier. So 2 lowercase is the same thing as uppercase, but in lowercase form. In this case, I just did the one example, which is storing it into a new variable. New word is equal to word.toLowercase. So let's go back over to the code to see that in action. So the very first thing here are these very first 2, shifting cases to and from upper and lower cases. And again, I'm actually storing them in the new variables. So for each one of these operations, I do the operation, and then I display the result on the screen. So you can actually see it. And over here, you can see the results. We have uppercase word, which is hello world, and lowercase word, which is hello world. We lost the capital H and the capital W there. Okay? Yeah, we'll leave that there for now. Great. That's our first one done. Moving on. Ooh, that's out of order. That's okay. Okay, let's go up to trim first. I don't want to go to value of. I will fix that later. Anyways, so what trim does is trim basically cuts off any white space on both ends of your text. So in the example here, I have this variable called phrase, and I put a whole bunch of spaces at the beginning and a whole bunch of spaces at the end. And then I said phrase is equal to phrase.trim. You'll notice in this case, I actually stored it back in the original variable. And the reason why I did this is typically those spaces are an accident. So you ask the user for their username or password, and they typed it in, they accidentally had an extra space in there. So rather than telling them that they failed at entering their password, you cut off that extra space, and then you test their password. So it's a way of trimming it off. Oh, I see that I forgot a semicolon there. Let's fix that. There we go. So it's a way of basically trimming that off. Okay, so that's all it does. There's nothing special there. Value of, this is a super powerful piece of code. And the reason why it's a piece of code, super powerful piece of code, is that it basically lets you convert almost any data type into a string. That's it. That's what it lets you do. And that's really useful for a number of things. If you want to start concatenating or doing other things with it, things like that, that's going to be a very useful thing. So look at this. Returns a new string version of the value given. Now, inside the brackets here, I wrote down nearly any variable type because it pretty much works with everything. So in this first example here, I said new word is equal to string. It's not any variable, it's just string. We're actually working on the object string itself. String.value of 10.2. So I put a double in there. But what does it give me back inside a new word? The quote 10.2, the actual string 10.2, 10.2. Here I'm doing the same thing with a Boolean variable. Boolean is summer, and I've assigned it the value false. So this time I'm getting the value of a variable. So here I got a literal value. Here I'm actually doing a variable. So it's going to go retrieve the value of that variable, come back, it says, hey, give me the string value of false. Well, it does that, and it stores the word false. That's pretty cool. So let's go back to our code so we can see this. So here we have trim, and I've trimmed off of word 2. Well, what's word 2? Word 2 I just created here with a whole bunch of spaces at the beginning and one space at the end, just to show you that it doesn't have to be equal in any way. And then inside for value of, I've converted 34.5, and that is summer variable. So you can see these, and over here we see trimmed. Now I know that this has actually been trimmed because we had all of those spaces at the beginning here. So if it wasn't, this high value would be way over here to the right. Now down below that for our value of logic, here we converted 34.5 to the word 34.5, and the value false to the string value false. It's hard to say that without it sounding confusing. I really don't think there's a way. Okay, so those are our easy ones. We got to get into something a little bit more complex now. Oh, another one out of order. I got to get on this. Okay, so let's go with this first one first. So text dot replace first. So let me try and explain this clearly. What it does is it searches for text B inside of text A. And the first time it sees it, it replaces it with text C. That's it. So in my example here, I say search for L inside of Word. And for the first time you find it, replace the L with a P. So hello world becomes heplo world. So it replaced the first occurrence of L with P. That's all it does. Here I'm doing it again to get rid of my space. I said replace the space with nothing. Literally nothing. So it actually cut that space out. This can be useful if you're trying to remove spaces. Now we wanted to get all user-friendly here, so I wanted to get rid of the word hell and put heck in there. So I said find me the first occurrence of hell and replace it with heck. So now we have hecko world. So replace first replaces only the first occurrence of a string with another string. Replace all does the same idea, except it doesn't just replace the first one. It replaces every single one of them. Now, depending on what your goal is, you may or may not want that. So looking at this, it says replace all L's with P's. So hello world becomes heppo werpid. All the L's were replaced with P's. Down below here, I'm saying replace all the 5s with asterisks. So our phone number, which was 1-555-123-4567, we got 1 ****. 1, 2, 3, 4, star 6, 7. Again, this can be pretty useful. And oops, didn't mean to do that. And then finally, we have this last one where again, I'm just replacing hell with heck. There was only one of them, so it replaced the only one that there was, Echo World. So let's go back and take a look at our code. So down here, I'm doing the exact same operations here. I'm replacing the L with the P, the space with the nothing, and the hell with the heck, and that's great. I'm going to show you, but this is all replaced first. So when we look at this, we get that Hello World, the Hello World without the space, and the Hecko World. But now let's do something much more interesting. Down here, I'm using nothing but replace all. So it says replace all occurrences of a string with another string. To show you that we can create a change that carries forward, I created a new variable called word3, and I named it, and I gave it the value happy birthday. And now I'm making changes and storing it back in the variable. So every step, you can see how it changes after every single step. And that's what I wanted to show you, because there's a lot of times where we want to make sequential changes to the same variable. So let's take a look. So here I'm saying replace all double P's with IR. So when we do this, we get Harry birthday. Yeah, Harry birthday. Awesome. Now the next one I said, now replace all A's with exclamation marks. So it comes through and the first A gets changed into an exclamation mark, and then that one at the end gets changed into an exclamation mark. All right. The next one says change all the I's. Well, this is interesting because for the first time, we're actually changing something that we already changed, because in that first step, we introduced a new I. So its current value is this, and now we're saying replace all the I's with double O's. So we have H exclamation mark, and then that I becomes a double O. So it's hey Yuri, and then the I in birthday, birthday. I don't know how to say that. I got nothing. And then finally, in the last step, I'm saying let's get rid of those exclamation marks. They're making things confusing. So we're saying change the exclamation marks to P's. So again, we go through the previous step and we say find all the exclamation marks and convert them to P's. So we get Hapuri, Borth de Peep, Borth de Peep. So all those exclamation marks were converted to P's. So that you can see how we can actually make successive changes. That is going to be fun to work with, especially coming assignment time. Okay, make sure I'm not, yes. All right, and now we get into the last one, which is probably the most important string manipulation command. I'm going to give you two versions of it because it's so bloody important. And that is text a.substring, and then I give it an index. What this does is instead of modifying a piece of text, it actually pulls out a chunk of text, a substring. A sub means part. A part of the string. So we're saying give us a part of the string, every bit of the string starting at whatever start index is. So when I say word.substring, it's going to go find index 5 of words, 0, 1, 2, 3, 4, 5, which is the space. And it's going to say cut out everything from there to the end of the word and give it to me. And that's what we did. We stored it in a new word. So new word actually holds space world. So think of it like a cookie cutter. We're cutting out everything from a certain location on. That's really useful. However, sometimes you may not want everything up till the end. Maybe you only want like one little piece of it. Well, that brings us to the next part of substring. Here we can give it a start index and an end index. So we can basically give it a range. What you need to realize though is you get everything from the start index up to the end index, but not including the end index. Oh, I know, confusing. So everything up to, but not including. All right, now that I've confused you thoroughly, let's take a look at an example. So here we have phone number. I'm going to cut up phone number. I want to grab the area code. So we have our phone number right here. I want to grab just the area code. That may be useful depending on what type of program I'm building. So I'm going to say, give me phone number dot substring starting at index 2. So 0, 1, 2, the first 5. And go up to index 5, but not including. So 2, 3, 4. So we get 5, 5, 5. And that's what we get put back into our new word variable. Okay. Now, that's fine. Sometimes you don't know how long your string is, though. Because again, the user might be typing it in, it might be created from other variables or some other form of data manipulation. So what if I want to grab the last character of my string? Well, then I can start to use all the other things that I've learned so far to work together. So I'm going to use the word.substring command. I'm going to try, my goal here is to grab that last character. So what is going to be my start index? Well, I want the last character, so my start index needs to be that last character. Well, how do I figure that out if I don't know the length of it? Well, I use my word.length command. So let's say assume that word is right over here and it has 12 characters. Now I say I want to start at index 12, but unfortunately 12 is too far because the last index is 11. So I subtracted 1. So length minus 1. Okay, we're sitting at the last character. Now how far are we going to go? Now remember, we got to go up to but not including. So this time I'm going to go to one bigger, which is going to be word.length. So really, because we don't include it, it actually is only going to grab that one character. That's it. So let's go take a look at that in code. So down here, I have a few different substring commands to show you. So this first one is the regular substring, which is just the 5. So in here, down here, we get substring, we get space world, great. And that's when you only supply it with one value, which is a start index. But when you give it 2 index values, a start index and end index, it will start at that first number and it will keep going up to, but not including the second number. So here we got the 555. And then finally, the last one is to get the last character of a word. So I said, go to the end of the string, minus 1, because the length of the string is 12, minus 1 is 11. That's our last character. But I need to get to the next one, because my end index needs to be the next one ahead of it. So that's just the word.length. Now that's fine, but is it super useful? Well, it depends on what you're doing. So I've taken this and I've applied it a little bit further. A lot of times when you enter your phone number or something like that on a website, they don't actually store it like that. That would be kind of silly for them. It's a waste of data. It's a massive piece of information that doesn't need to be like that. Instead, they're actually going to store it as like a number, like an actual number. So what they're going to want to do is they're going to want to cut out all those special characters, all the spaces, all the dashes, maybe the brackets, depending on what's going on there. And the way they're going to do that, well, that's up to them. So I'm going to show you 2 strategies to solve that problem. So the first strategy is I want to get rid of, remember, our starting phone number is in this format. And I want to get rid of all the non-number characters. So I want to get rid of the spaces and I want to get rid of the dash. So the first way I'm going to do that is using the replace all format. So I'm going to say replace all my spaces with nothing. So that's going to get rid of the space in between the 1 and the 5, and then the next space between the 5 and the 1. Okay. But I still need to get rid of the dashes. You notice that I stored it into new word. I'm not changing the phone number. Stored in a new word. But now I'm going to manipulate that new word and store it back in a new word. So the phone number still is its original state. So here we have new word is equal to new word.replace all. This time get rid of the dashes. And again, I'm replacing it with nothing. So this solved my problem. This got rid of the spaces and the dash. So now I have a simple value. Then I could store that inside of another variable. Looks like a double probably. How many digits we got there? Yeah, it looks like you're going to need a double to store that because it's too big for an integer. And the last one is using a combination of concatenation and the substring method. So this is actually just one command. I just formatted it nicely so it looks pretty, but in reality it's just one command if we look at this. So what I'm saying is I'm just cutting out the original text. I'm cutting it up to find all the number values. So I'm saying, okay, start at index 0. Let me write the actual phone number here so you see it. So what it looks like, 1 555 123 dash 4, 5, 6, 7. So what we're saying is start at index 0 and go up to index 1, but not including it. So that gives us the first character. Okay. Now I'm going to concatenate, because these are all strings, concatenate that with the area code, which is index 2 up to index 5, which we saw way up here somewhere, right up here. So again, I'm concatenating. Now I got to grab the residential code, which is that 1, 2, 3. So I'm going to say start at index 6 and go up to, but not including 9. So 6, 7, 8. And then I'm going to grab the last piece, which is going to start at index 10. 9, 10. You notice I didn't give an end index this time because I just want the rest of the string, so there's no point. So that's all I did. This one is building a new string out of pieces of a string. So there's two strategies here. So this one manipulates and creates a new string by modifying, modifying, modifying. This one just says, nah, I'm just going to cut it up and build a brand new one. So they're two different strategies, two different schools of thought, and it's up to you depending on what your strategy is. And in this case, they're both probably pretty equivalent in terms of efficiency, relatively close anyway, especially on this size of a piece of text. If it was much larger, we'd have to analyze this and figure it out in more detail, but this is probably fine for now. Okay, so now you've seen all these different string operations and how to apply them in unique ways. Your next tasks are going to be using these things, so good luck.